This is the review for it. So what is on the exam? We said that we're going to have chapters 1 and 2. And then I'm just going to say plus 3.1 since those limits are in, as I said, 2.3. The limits we did earlier today are already in section 2.3. So I will not ask you to find the derivative because that's the wording that it's for next test, which is kind of ridiculous, but okay. But the limit procedure for the derivative, you are responsible for that because it is the difference quotient is reviewed in chapter 1, and again, these limits were done in 2.3 and then again 3.1, so they're all over the place. We're focusing on limits, obviously. The topics is pre-calc, very few things from pre-calc that I am interested in, mainly computing f of x, which means do you know how to plug in a value and get the number on the other end? Talking about function compositions, which means, well, you have first function combinations. Can you add functions, divide functions, multiply functions? And then we have function composition when you plug one function into another. That's that FOG, right? FOG. It's function composition, also known as f of g of x, right? Do you know how to plug one function into another function? That's going to be extremely important for our chain rule in chapter 3. It's coming up. Also very concerned with the inverse. So do you know the function f versus the f minus 1? You know how to get it, right? Swap x's for y's and then solve the algebra to get y equals everything else. Vertical line test to spot the function, horizontal line test to spot which functions have inverse functions. So that could be there. And let me write it in red. Definition of a function. Remember on the first day I said function is a rule which assigns to each x in the domain a unique y in the range. That will be there for 4 points, 100%. I'm telling you right now, a question that is going to be on the test. That wording is necessary. The 4 words, which are rule, domain, range, and unique, need to be there for the full credit. There's no need for you to write examples or write paragraph or a story. It is very simple. You state the definition. Function is a rule which assigns to each x in the domain a unique y in the range. That one will be used in this class, and then in Calculus 3, the same wording will be redefined for 3D and more. What was the question? Function is a rule which assigns to each x in the domain a unique y in the range. Then we are moving with chapter 2 stuff. Chapter 2 is on limits. And you are going to expect definitely computing limits. And computational limits breaks down into 3 different ways. What are the 3 ways? Algebraic, which means, which is plug-in. What else is under algebraic? We have rationalizing, right? We have factoring, eventually canceling. All of this stuff is in 2.3, right? All of it. What are the other two ways of figuring out what the limit of a function is? Yes? A table of values, very good. Where you pick, let's say, 3 numbers or 4 numbers that are smaller, and then 3 or 4 numbers that are larger, and you check if all of those values go into where the y values go. Great. And the last one is graph. Now, as the offshoot of this, I will say, look at the graph. Look at the given graph to find the limit. That is that situation we had right when you have that elaborate graph that does things, right? And then you look at it. We'll take a look at the example if you have questions on it. So computing limits. We are also going to look at the infinite limits. And limits at infinity. With all of their vertical asymptotes, horizontal asymptotes, slant asymptotes, and behavior of a function. So all of those are there. So there could be a very easy question. Prove that function so-and-so has a vertical asymptote at 3. The question sounds like, wow, prove that, right? I already gave you that there is a vertical asymptote at 3, so there is no need to set the denominator equal to 0 and do anything else. All you need to do is to do the limit and then write that sentence at the end which states, because the limit is infinity, we have vertical asymptote. Or because the limit is not infinity, we do not have vertical asymptote, right? So that's that part on those. And then we have continuity. Which are 2 at the point and global. So at the point, that's those 3 rules that you need to know. Can anyone tell me what the 3 rules are? Yes?
That f of a exists, the limit of x versus a exists, and that 1 and 2 equal each other.
Nice. So the 3 rules are that the function value exists, the limit at that point exists, and they're the same value. So that's awesome. Those are the 3 rules for continuity. Now, global continuity states that if the function is continuous at every point, function is globally continuous. But we have the another theorem there which states that all polynomials are always continuous. All logarithmic functions are continuous, exponential, sine, cosine. So there's that whole list that was given of continuous functions. And then combinations, another theorem that says combinations of those functions are continuous functions, and even the composition of continuous functions is a continuous function. So all of those, so continuity, and I will say plus rules, right? Rules. Now, in terms of definitions plus theorems, right? What are the things that you need to know? We start with a definition of a function. We start with the definition of a limit. That's 2.7. Remember that? And then a theorem for existence of a limit. I hope you are remembering that the limit from the left and limit from the right have to be the same. So that's that one, the major theorem. So if the limit from the left and the limit from the right are the same, then the overall limit exists. That is the big one. And then we have all the, well, the 3 rules for continuity. I'm sorry, I'm skipping around. I was supposed to say vertical asymptote, horizontal asymptote, right? Those statements. You know that if the limit going to infinity, either from left or right, is positive infinity or negative infinity is finite number, you have a horizontal asymptote. If the limit as x goes to a of a function is either positive or negative as you go from a minus to a plus, is infinity, then we have vertical asymptotes. So those are the definition or the theorems, definitions for vertical and horizontal asymptotes. And I think that covers it all. So these are the ones that you are stating as formulas. I mean, you should know, obviously, the theorems for continuity, right? Which functions are continuous. Let's put that list of continuous functions. Right, that's extremely important. And then you have the theorem that any combination of continuous functions is a continuous function. And that solves it. You had your hand up.
Are we going to define the asymptote?
If I really run out of the stuff, but most likely it's a long division. Something you learn in algebra and forget next day. Well, was that a true statement?
Falls under that criteria.
Falls under that criteria, right? Yeah, there's a lot of stuff here, but technically, as I said, 10 questions, possibly that 11th replacement problem.
What's the replacement problem?
The one at the end of the test that can replace any problem on the exam. So if it's there, you can use it to replace any problem. As I said, for someone it's going to be problem number 3, for someone it's going to be problem number 7, for someone it's going to, right? I learned that from my physics professor. He always put 5 questions on the test and then the replacement problem at the end. He said, you know what? Sometimes you can't remember how to do one thing. It's not that you don't know it, it's just that you're so freaked out on a test that, I'm going to play some, maybe we'll see, maybe we do rainforest, maybe we do just rain, maybe we do, thundering rain or something that is going to go in the background to relax you. Put the pictures of puppies and kittens over there, and yeah, it should be zen for the test. Yeah, you never took the test like that before, so we'll see how it goes. All right. That's all I had to say. So the exam goes for about hour 20, hour 25, 10 questions, and then no bathroom during the test, so go before. And if you have to go to the bathroom, just hand in the test and then go. And that's it. So make sure you bring some kind of sugar or something, in terms of the energy drink or Red Mountain Dew or chocolate bar or something. I guess, especially if you're diabetic, then bring a lot. It's calculus 1 test. No one caught that reference. Fine. Do you have any questions for me in terms of problems, concepts, anything that? Yes.
Can you go over the rules for horizontal asymptotes a little slower? I remember, aren't there like 3 separate rules for where the exponent is, either linear or...
Yeah, those 3 rules you memorized in pre-calculus because you did not have a definition of the limit. You can still use it. But if the problem says prove blah, 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 then you can't use those. The limit definition for the horizontal asymptote, right? So horizontal asymptote occurs where you take the limit x goes to either positive or negative infinity of f of x and you get that L, then y equal L is horizontal asymptote. So that was the definition, and that's the end of the story. Now, the pre-calculus 3 rules for a horizontal asymptote state that if the highest exponent in the numerator is bigger than the highest exponent in the denominator, then you have no horizontal asymptote. If they're the same, you take front coefficients. If the one on the bottom is higher, then it's 0. But all of those 3 cases are consequences of you computing this limit. So you computing the limit is the proof for the asymptote that exists there, and that's why you can just forget those rules. See, for the vertical asymptote, you need the rule denominator equal to 0 because you need the candidates where to do the limit, right? The vertical asymptote was, definition, was limit x goes to a, either plus or minus, of f of x needs to be plus or minus infinity. And if that's true, then x equals a is vertical asymptote. But in order for you to do the limit, you first have to have numbers that will be plugged in for that a. So when you do denominator equal to 0 for vertical asymptotes, you will get maybe positive and negative 3, like we did in class, or 5, whatever we had. And then you check both of those numbers one at a time and see which one is the horizontal asymptote, vertical asymptote, and which one is that maybe a point. Maybe both of them are vertical asymptotes. Yes?
Do we need to know the intermediate value?
Not for this one. We'll do it for next one.
If you do one of the problems where you have to divide by like the highest exponent.
Yeah, that's the horizontal asymptotes. Do you have a problem? Can you inquire the problem? You can inquire the problem.
It's really just sort of like one that was on the lab.
Yeah.
So like we can't go over that one specific.
Yeah. So just take the book from him, find it until I answer his question. Find the problem. Here's the book right there. Yes.
This is going into more like linear algebra. Why do we need to use the intermediate value theorem? Because really all it says is if a function changes heights, then there's going to be a point in between.
I'm going to actually have a whole talk on intermediate value theorem in chapter 3 at some point. That theorem actually allows us to solve equations. It is theoretically extremely important theorem that has no practical value to us today because we have computers and calculators and so on. But it can be used, without calculators. So, paint the picture: you're on a desert island, the battery in a cell phone ran out. You don't have the calculator, and the Wilson is gone. You have nothing to do. So stick in the sand, and you. That's the first one. All right. That's the first one. I've never heard that argument, so which completely ruins my my desert island thing. I will have to come up with something else. So consider yourself accomplished with a comment for today. You find the problem?
I think so.
You think so?
Yeah.
What's the page?
96.
96. And what's the problem number?
I think it's any of the ones from 9 to 14.
So which one? Pick one.
Alright, I'll go with 13.
I knew it. I knew it. As I looked at this, I said, it's got to be 13. Otherwise, you failed. I'm not failed the class. I mean, you failed picking a problem. All right, so we have limit of x goes to infinity of cosine x to the 5 divided by square root of x. Awesome. So what is the exponent that we want to use here? Well, technically, you can use any exponent you want, right? But let's see. The trick for any of these limits that involve cosines and sines, and later on for Calc 2 purposes and so on, is to realize that cosine of whatever over here is bounded by 1. So technically, as soon as I divide it by x or something, the whole thing is going to go to 0 because cosine and sine are always between 1 and -1, hence the absolute values there. So the value of the numerator, never exceeds 1, and the value of the denominator, right? The value of the denominator is going to go to infinity because the square root of infinity is infinity. So in the long run, we have just 0 here as the answer. Because technically what you have is 1 over infinity. Does this make sense? Awesome. Next question.
I think number is like 37 through 57 on the chapter 1 homework. There was a lot of like sine, cosine functions. Could we just do any one of those?
Wait, you said on the homework? Oh, that's the online homework.
Yeah.
So let's take a look at chapter 1. You pick a problem there. Remember, I'm not picking any problems. So that's the review exercises in the textbook. We said a lot of them with sines and cosines. Can't find any now. Aha. Well, they graph sines and cosines, matching a function to a value. Aha, probably you are looking at these. So I'll switch the projector so you can see. So these are the ones that you are, page 53.
Yeah, honestly, those are all pretty good.
So what are your questions?
Could we do problem number 39?
39. All right. I hope we can. This is chapter 1 review. So, and this was problem 13 somewhere. The 2.5? Yeah. So 39 says sine inverse of -1. So inverse sines and cosines evaluate or simplify the following. Okay, so concept-wise, we said that y is equal f of x, where x is the input and y is the output. Now, what I'm going to do here is I'm going to say that if you swap.
Are we supposed to be able to see what you're doing?
Yes, you are supposed to see what I'm doing. Can you see it?
Yeah.
All right, good, no complaints. You're supposed. No, thank you, because switching these things. I mean, I see it all the time. It's right here, so I see both of them. That's why I use 2 computers. So y is equal to f of x. X is input, y is the output, and then swapping x and y brings us into inverse, right? Where you get x is equal to f of y, and then you solve for y. You get y equals f inverse of x now, which is the inverse. So with that being said, when you say sine of pi over 6 is equal to 1/2, this thing over here is the angle, and the output is the number. If you have the inverse sign, then the number has to be the input and the angle is the output. So technically, if you are asking yourself what is this equal to, you might as well ask yourself what is the sign of what value is -1. And the fastest way probably to answer that would be to draw a sign graph and just use your eyes and look at it, which quickly brings you to a value of x is equal to 3 pi over 2, just by looking at the graph without going crazy. But then you understand and you know that sign goes forever to the left and to the right. You will have infinitely many answers. So equivalently, you can answer that it's negative pi over 2, because here's the -1 again, right? The value -1 is happening at negative pi over 2 as well. So, many answers here. Being that this one is actually the principal value. Negative pi over 2 is the principal value because we restrict the inverse sign from negative pi over 2 to positive pi over 2, so we can make it into a function. Because sine function that goes from negative infinity to positive infinity fails the horizontal line test, which means that its inverse is not a function. But if you restrict that on the restricted domain from negative pi over 2 to pi over 2, you do get a function. And that's good. Yes? All good. So if you give me the problem, we'll write that problem. So what does it say? Okay, so we're going to pick either positive or negative infinity because it's going to give us the same answer no matter what. So we're just going to choose the positive infinity in this case. And then we're going to go from... all right, so let's see. This is actually... So find the limit. That's the question. And I'm just going to say horizontal asymptote over here, because this is the definition for horizontal asymptote. If this works out to be a finite number, you will have horizontal asymptote at that value. If this turns out to be infinity, that means no horizontal asymptote for this function. That's as simple as this. Now let's go and do this. So when you see this configuration, we learn in section 2.5 that we are supposed to divide every term in the numerator and denominator with the polynomial of the term with the highest exponent, in this case x cubed. So the setup is limit x goes to infinity, and we are dividing 3x cubed by x cubed minus x divided by x cubed plus 1 divided by x cubed, and in the denominator x divided by x cubed plus 3 divided by x cubed. In the first one, they cancel, and every other one will go to 0, because when you cancel them and you put x in the denominator, right, which is infinity, you get number divided by infinity, which, remember me ripping the paper in class as an example? In every case, it's going to be a 0. So we are getting here at the point where you are getting 3 divided by 0. Right? You get 3 divided by 0, which means limit does not exist. In this case, implying horizontal asymptote does not exist. Yes?
Was this how the slant asymptote?
Slant asymptote only occurs when the exponent in the numerator is by 1 higher than the denominator. By 1, because when you divide them, yeah, you get the linear line. which is the slant asymptote. So a case, let's say 2x cubed minus 5x plus 3 divided by x squared plus x minus 1. It's x cubed on top, it's x squared on the bottom. When you do the long division of polynomials, you will get the slant asymptote. And slant asymptote is always y equal mx plus b, right? Because when you look at the lines, the horizontal asymptote is this one, which is y equals a number. Then vertical asymptote is that one, x equals a number. And then you have a slant asymptote, which is y equal mx plus b. You will, and that mx, right, the mx term, you see that x is the first power. That's why it's required to be by 1 off. Because when I divide x cubed by x squared, I get exactly 1. Or x to the 10 by x to the 9, I get single power of x. So that's why that's the rule for slant asymptotes.
Another question.
Yes.
About this one we just did. Say we get a question like that on the test. You want us to do it the long way and prove it by dividing by all of those? Or can we do it the quick way where when we
Well,
know
slant
that-
asymptote has to be done by long division.
No, I'm not talking about the slant. That one right there. You know, the quick way when the degree is higher on the numerator, you can just say this.
Yeah, but see, the calculus is very strict in terms of it says prove that.
That's what I'm asking.
Right.
You want us to do this.
Prove that means you have to do the limit. If it just states what is the horizontal or vertical asymptote, you can do whatever the hell you want, right? But the word prove immediately means that you have to use the theorem for it, which is doing the limit. Yes? Same. Does not exist. That's, yeah, but for the vertical asymptote, we have to check x approaches 3. Right? The vertical asymptote, the difference between the horizontal and vertical asymptotes is, here they are, right? So for the vertical asymptote, you will have to approach 3, which is the one that makes denominator 0. Negative 3. Yeah. Where the infinities are for horizontal. Anything else?
I have a question on the problem. What if the highest degree so the problem is saying that you split by 3x.
Well, in that case, all of this would work out to be 0. Because you would have 0 divided by 3. If you just swap numerator and denominator, calculation will stay the same, dividing by x cubed everywhere. It would just be 0 divided by 3, which is 0. In that case, you do have horizontal asymptote at y equals to 0, which is x-axis. Makes you nervous, right?
Will there be any word problems?
Unfortunately, no. This is I guess the most boring exam of your lifetime. It's just gonna be calculations, no word problems. We will catch up on the next test. It's gonna be plenty, at least 2. Any other questions regarding the exam? For the review, any of the problems? Horizontal asymptote we just did. Vertical asymptotes are looking for infinities. The difference between vertical asymptote and a point. The graphs telling what the limits are, whether the limit does not exist, right? The jump discontinuity. Anything? Yes?
I have an inverse question from the chapter one. I'm pretty sure this is the question the way I wrote it down. It says f of x equals x squared minus 6x plus 10. And then it says for x greater than or equal to 3.
Plus n.
Plus 10.
10.
1, 0. And yeah, it says find the inverse of that.
Find the inverse. Great. So what we know here is find the inverse function. So what we know here is that looking at the function given is that we have a parabola, and a parabola is the U shape. Since it's a U shape like this, when you find the inverse, it's going to look like that, and that fails the vertical line test, which means it's not going to be a function. Now, we're lucky with this domain restriction because that's going to cut off a portion of the graph, and we're hoping not to have the graph like this, but we're hoping just to have this much, and in that case, we would be able to find it. So the first thing that I have to do is I have to do the completing the square procedure to find, well, actually, we can get the vertex using the formula. Let's complete the square for fun, and then we'll use the vertex as well. So you pick whatever method you like more, and then do the other one. I know that made no sense. Let's first do the completing the square. So completing the square is done is you group first 2. And since x squared has coefficient of 1, we don't have to do anything else. We do b over 2 squared, which is negative 6 over 2 is negative 3 squared is 9. And that's the magical number that we add to complete the square. So we add 9 and we subtract 9 inside parentheses. We still have plus 10. So the first 3 give us completed square, which is square root of the first, sine of the second, square root of the third, and then plus 1, because minus 9 plus 10 is plus 1. So now, this allows me to graph the function easy because I know that the vertex is at 3, 1. And that's awesome because if you're looking at our restricted domain, the function is to start at 3 for x's. So my graph for this is that, which is awesome. So now what I can do is I can quickly swap x and y. So x is equal to x minus 3 plus 1 squared, sorry, and just solve it. Whoa, hold on, this y. And just solve it for y. So we have x minus 1 is equal to y minus 3 squared. Now when you square both sides, square root both sides, you must put plus and minus. But because of the restriction that x's are bigger than 3, we can drop the negative because we only have one branch. So this quickly becomes the square root of x minus 1 is equal to y minus 3 because the square root and the square cancel. And we lose the plus minus because we're just going to use plus because it's only a half the positive half of the graph due to the domain restriction. So now y is equal to square root of x minus 1 plus 3. And you can graph it now because you know how to do that. Minus 1 shifted to 1 and then plus 3 units up. So right there, and it's a square root like that. So that's 1, 3, x and y. That's a very good problem. I should consider this for future generations. Domain restriction is what makes it work. This says function over here. It's ugly. Yeah, there's much more than that. You can literally just use the, let's go over here, or negative b over 2a. If you use that formula, which gives you the vertex, negative b over 2a, that's going to be 6 divided by 2 is 3, which is this value here. And compute 3 in this, you will get 1. So this will give you 3, and then you go f of 3, which is 9 minus 18 plus 10. 9 minus 18, right, is negative 9 plus 10 is positive 1. And then you can use that if you know the form of y equals a x minus h squared plus k. And you just computed your h and k. This is your h, this is your k. And a is 1 because that's the coefficient of x squared. Depending on how much pre-calculus you know, and depending on which type of, which algebra is easier for you. I always do completing the square because I can skip like 3 steps and get it. Vertex is always less, even though by the end of this class, not this class today, but calculus 1 course, you will know that you can take the derivative and find the vertex instantaneously for these things. Well, it's the part where I squared both sides and then I threw away the minus, which is, yeah, see the plus minus here? No plus minus here. I eliminated the minus because the plus 3 by all x is larger than 3 is just telling us to keep the positive branch and forget about the negative branch, which is what makes it a function of square. Yes? Yes, for the polynomial of the second order for a parabola. Yes, you're right.
Okay, so just to visualize that, because it would be the zeros of the derivative, that would mean that it would be where the slope is 0 and where.
Very good. All good? You want to take a look at your labs more? They're due tomorrow. Make sure you print out the software requirement.